In this video, we're going to have a look at DC and AC currents. This lab power supply is an oldie but a goodie. It's got DC and AC currents, and I really like to use it to demonstrate the difference between DC and AC. DC stands for direct current, and what that means is that the current is always moving in the same direction. It means that negative, or ground, is always negative, and positive is always positive. This is quite different to AC. AC stands for alternating current, and that means that the negative and the positive switch between the terminals. In the world of digital electronics, we're always interested in DC. Now, if we have a look at our multimeter here, there's a few clues to see what DC and AC is. Here we have our multimeter set to our voltage range, and we can see that it's set automatically to measuring DC. This is great for things like batteries. Now, if we change the mode of our multimeter, we can see that we've put it into the alternating current mode. I want to do some testing on this, so let's have a look at the DC first. I'm going to use my parrot clips. You can see here that I've just used some solid core wire and I've tied it down onto the binding posts. And I'm going to hook the red probe up to the positive and the black probe up to the negative. And straight off you can see that our multimeter is telling us it's about 5 and a bit volts. That's interesting because the little dial is set to 4 volts. We'll have a look at that later. Now I've done the same thing again, but I've hooked up the multimeter to the AC binding posts. And you can see here that it's not measuring any voltage. That's the problem. See, it's still set to DC. I need to press the mode button and change it to AC. And now we can see that we've got 4 and a bit volts AC. Now, to demonstrate what that power supply is doing, I'm going to draw a little graph here. On this axis here, I'm going to draw voltage. And on this axis here, I'm going to draw a time scale. Not in seconds, but in some arbitrary time figure. I'm going to call my time scale Who's-a-me-what's-its. Here I'm going to, at time 1, I'm going to say that's like 4 and a bit volts. So now at time 2, at time 3, at time 4, at time 5, at time 6, at time 7. Alright, this is all getting a bit boring and repetitive. If we have a look here at what the voltage is doing, the voltage has changed over time. It hasn't always been 5 volts. Wouldn't it be great if there was a machine to help us do this? Some kind of a machine that would graph the voltage in some time scale. In fact, some more accurate time scale than Who's-a-me-what's-it. Wouldn't it be great if there was a timescale in milliseconds or microseconds? Well, such a machine exists and it's called an oscilloscope. This is an oscilloscope and it does exactly what we need. It graphs voltage over time and it tells us the scale. It tells us the scale here. This says that each square is 5 volts. It also says that each unit of time is 5 milliseconds. To plug the probe in, the probe is keyed and the key has to match the key on the connector. Put the negative clip on the negative and then we're going to probe the positive. Now we'll turn it on and we can see what this power supply is doing. We can see that that DC is fluctuating wildly. In fact, it's fluctuating at something like, I don't know, what's that? 100 Hertz. Here we've got our waveform and we can see down here that those little squares are measured in units of 5 volts. So that's 0, 5, 10 volts. So this is somewhere between that. So something about 7 volts. And you can see up here, it's telling what the maximum voltage reading is. Down here, it's telling what the frequency of this is. It's measuring the distance between here and here and scaling it in seconds for us. Our time scale is 5 microseconds, so every scale this way is 5 microseconds. 5 microseconds, 10 microseconds, 20 microseconds. Wouldn't it be great if we could change this scale? That's what all of these fancy buttons do. This button here changes the voltage axis, and you can see it's changing the scale here. This button here changes the time scale axis, and you can see that getting smaller and wider now. Now I've changed the connections over to AC, and we can see very clearly here that the power is changing positive to negative. So here's 0, and here is the cycle where it's positive, and here is the cycle where it's negative. You can see that the power is changing directions. And that's what alternating current is. It's current that alternates between positive and negative.